Alright, so where are we going now? Yes, we're doing differentials of tutorial 7, and we're looking to differentiate a couple of things from first principle. So that's what we're up to at the moment. Alright, so let's just keep on with it. So we've got function of x. We're looking to do our first principles. So from that we can take our tangent gradient is rise over run then we've got f dash of x, and that will be equal to the limit as h approaches 0, so that's our insurance policy of f of x plus h. So that's the upper part of the rise, that's the lower part of the rise, and we've got the upper part of the run, subtract the lower part of the run. So we get those cancelled, and we just get that with those functions. So for this particular example, we will be the limit as h approaches 0 for everywhere there's an x and an h. X plus h all squared plus 3 everywhere there's an x and an h, so you've got to obey the algebra, summing, and plus 1. Then we've got this subtraction here, and then we've got f of x, so we've got x squared plus 3x plus 1. Now I'm going to put it in a bracket. I know it's not in a bracket up here, but I'm going to put it in a bracket just because I want to remind us that we have to do an expansion. Alright, we can't have a quotient that's 0, so that's why we've got our insurance policy there. Value never actually takes on 0, but nevertheless. So we've got the shortcut, x squared plus xh times 2, 2xh plus h squared, and expanding the next one, plus 3x plus 3h plus 1, and do the expansion across this bracket, minus x squared minus 3x minus 1, and all of that sits on top of h. So we'll just find the things that are cancelling, x squared, 3x plus 1. So we're left with our insurance policy, two xh. Let's just put the higher power first. It's 2xh plus 3h. That's all we have left. Terms with h in them. So what's common across the pluses? H is common. So our limit of insurance policy, h approaches 0, will be h. That's out of h plus 2x plus 3 divided by h. So we end up with those cancelling. So this h will disappear. We end up with 2x plus 3. Now, of course, that's what we're used to. We're used to saying f dash of x is equal to 2x plus 3. But from first principles, that's what we did. So that's very good. All right. The next thing we want to consider is B from first principles. So we'll do B from first principles. Bring this up. So we have f of x is equal to x squared minus 4x minus 9. So our tangent is rise over run, which is f dash of x, which is the limit as h approaches 0 for our upper in the rise minus our lower in the rise, and then run our upper, and there you have it. So they cancel, just like with h. Alright, so if we go ahead and put the things in, everywhere there's an x, add an h. Minus 4, put a bracket in for algebra, and minus 9, minus, now put the bracket in just to isolate all those terms, and all that over h, provided you've got an insurance policy. Okay, so limit as h approaches 0, x squared plus xh times 2 plus h squared minus 4x minus 4h minus 9 minus x squared plus 4x plus 9 all over h. So we get the cancellations in 9 plus 4x minus 4x, x squared minus x squared, so all the apples minus the apples are gone, and limit as h approaches 0 is h squared plus 2xh minus 4h all divided by h. So we'll take everything's across a plus minus. We'll take an h out as a common factor. We'll do that with 2x minus 4 over h. Now that will cancel. So you'll have to look at the limit as h approaches 0 for h 2x minus 4 plus h, so h approaches 0 without taking it on, but when it's sufficiently close, our derivative is 2x plus 4. For all intents and purposes, the h approaches 0. Alright, so fairly straightforward in terms of that part. Alright, question 3. If we've got a polynomial, find the derivative, the gradient of the tangent at a point on the original curve. So it's a bit more of a practical application of the differentiation. So for part 3, f of x is equal to a half x4 minus x cubed plus 6x squared. Alright, so we'll go and find the derivative. So we're going to do up and under. But we already had a half. Up and under. Up and under. And 2x becomes 2x squared, and where there's no variable, we conjure. So we're taking the derivative. Actually, I've done that wrong. I've just been teaching integration all morning. Oh dear, Jason, that's not good. I just integrated all of those terms without even thinking about it. Up and under, I even used the term. That's very silly. Alright, I apologise. Right, 4 out the front. 4 minus 1 is 3. 3 out the front. 3 minus 1 is 2. 2 sixes are 12. Minus 2, and they're gone. Very straightforward. Oh dear, oh dear. So 4 over 2 is 2x3 minus 3x squared plus 12x minus 2. So that's the quick approach. Alright, the next thing we want to do is find that at the point xy. So we have to do function notation at 2. So everywhere there's a 2, where there's an x, we put a 2. Plus 12, 2, minus 2. 2 twos are 4 twos are 8, 2s are 16, 2 twos are 4 threes are 12, 2 12s are 24. Okay, so we've got 16 minus 12 is 4. 4 and 24 is 28. 28 minus 22 is 26. So that's the m value. That is the gradient. mt at 2, 12, or 221. That's quite steep at 221. Now all I asked for in B was to find the gradient of the tangent at the point. It didn't ask for the equation. I think that's going to happen in the next particular one. So just moving this out of the way. And okay. All right, so let's just continue on. And so let's just continue. Okay, so we've got time. We're only 13 minutes, so we'll keep going. So for question 4, it's going to ask for a bit more information. Now it's just gone away from y to f of x to y. So we've got A, find the gradient, y dash, 2x minus 3. Is that plus 3? A minus 3x, x squared minus 3x plus 5. So it's 2x minus 3. For part B, it wants the gradient of the tangent at the point 2. So using function notation, we're going to put x as 2 in there, and everywhere there's an x, we'll drop a 2 in. So 4 minus 3 is 1. So the gradient's like y equals x. Alright, the equation of the tangent and the equation of the normal. Okay, so this time we've got y equals mx plus b, and we have our m, we have y and x, which is solved for b. So y is the point 3 equals 1 times 2 plus b. So 3 equals 2 plus b. So subtracting 2, b is equal to 1. So the tangent is x plus 1. Alright, the next thing we know is that mt and mn are equal to minus 1. So therefore mn is equal to minus 1, and dividing by mt, which itself was 1, is negative 1. So for part D, the equation of the normal, we go again using the same parts, but this time with a change gradient. So we get the y value is 3, the gradient is minus 1, x is 2, b. So it's minus 2, 3 equals minus 2 plus b. So adding 2 to both sides, 5 is equal to b. So our normal is negative x plus 5. So that's our second part. So we've got yt equals x plus 1. And you can write that as yn equals 5 minus x if you wanted to. I'm just following the convention that we use, y equals mx plus b. Alright, so that takes us to 4. So what I'll do is put the simple derivatives. I'll have a break here now, and I'll be back soon. That was part 2.